Today's lesson is on one of my favorite principles, Le Chatelier's principle. You'll be interested to know that Le Chatelier actually traveled over from France and lived on the main street of Highbridge for a few years, worked down at what is the now Taylor Warden complex. So there's a little trivia for you on Le Chatelier. Anyway, his principle states that when a system is subjected to a stress, the system will shift its equilibrium point in order to relieve that stress. So we're talking about equations. So when a reaction is stressed by us changing it somehow, it's going to compensate for that. And so we're going to look, again, we're going to keep looking at this Haber process reaction. And we're looking at nitrogen plus hydrogen yields ammonia, and then we have our energy put back in. Think for a minute about what type of reaction this is. Is it endothermic or exothermic? And if you said exothermic, then you're correct, because our heat is a product. So if we increase the concentration of any component on the left, if we increase anything on this side, the reaction's not going to be happy. It's going to be kicked out of equilibrium. So in that case, it will shift to the right. It will shift this direction to compensate for it and increase the production of NH3. So if we put, sometimes you'll see little arrows like this. So let's say we chose to increase N2. If we increase N2, the reaction is going to shift away from that increase, and it's going to point this way. It's going to make more NH3. In the process of making more NH3, it's going to release more heat, and it's going to consume some of that H2. And if we look at it in terms of H2, if we were to increase H2, same thing would happen. It would shift away from that stress, the NH3 would go up, the heat would go up, and the N2 would go down because it would be consumed in the process of making the NH3. So what we're looking at in that case is a shift to the right. If we decrease the concentration of any component on the left, so let's say we decrease this H2, the reaction is not going to be happy that it's missing one of its components. So by decreasing, we're taking it away. We're taking the hydrogen away from that reaction. So it's going to shift to compensate for it. It's going to shift to the left to try to make more of it. In the process of doing that, the NH3 will be used up. The 92 kilojoules won't produce as much heat, and some N2 will be made. Same thing would happen if we chose to decrease the N2. It would still shift to the left. And I always circle the ones that we're causing the stress on. If we decrease the volume, which will therefore increase the pressure, it's going to compensate by looking at the moles of gas. So in this case, I have on this side 1 mole plus 3 moles, so I have 4 moles of gas. And this is only gases that it looks at. If there's any aqueous, liquid, anything else in the reaction, it's not a part of it. And on this side, I have 2 moles of gas. If I'm increasing the pressure by decreasing the volume, it's going to shift towards the side with the least moles of gas. It's going to shift to relieve that pressure. So it's feeling very compressed and pressurized. It's going to go to the side where there's less moles of gas. And so in this case, it's going to shift right, but it's going to favor the process producing the least moles of total gas. Okay, so in this case, the opposite is true. If we increase the volume and decrease the pressure, so it will shift towards the side with more moles of gas in that case. Okay. If we, which is just what I said, if we increase the volume and decrease the pressure, it's going to favor the process with the most moles of gas. So it says, oh, I have all this extra space. I can fill up this extra space by going to the side with more moles. If I increase the temperature, now if I'm dealing with temperature, I'm dealing with basically these kilojoules. And so I'm going to treat this just like I did the concentrations. If I increase this, which way will my reaction shift? If you thought it would shift away from that, you would be correct. It would make more of this and less of that. So it's going to favor the process that that uses up the energy or that shifts away from that energy. And then if we decrease the temperature, okay, very similar thing. If we bring this down, it's going to say, hey, wait, we're taking away heat. I need to shift this direction. I need to make more ammonia. And in that case, those will get used up. So it'll favor the process that produces energy. So let's take a look at one more example. So we have carbon monoxide plus oxygen to make carbon dioxide. And again, this is an exothermic reaction. If we take away the CO2, we're going to remove the CO2. Which way will this reaction shift? Well, it's saying, well, hey, you're taking away my CO2. I need to make more. It's going to shift this way. It's going to shift this way. These two will get used up in the making of more CO2, and the temperature or the heat will increase. So it'll shift to the right. If we increase the temperature, in that case, the reaction is going to say, hey, wait, it's getting too hot in here. I don't really like that. So I'm going to shift away from that. It's going to point this way, which will make more carbon monoxide and more oxygen, and my CO2 will decrease. If I decrease the pressure, in this case I'm looking at moles of gas. So decreasing the pressure, I have 3 moles of gas on this side, and I have 2 moles of gas on this side. If I decrease the pressure, I'm going to go to the side with more moles of gas. So in that case, I can just go ahead and circle my shifting arrow because I'm not changing the concentration of a reactant or a product. If I'm going this way, my reactants will go up and my things on the product side will go down. And if I add neon, neon's not part of the reaction. And so that's sort of weird. But what it's going to do is it's not going to react with anything because it's a noble gas. And so in this scenario, it's always going to be a noble gas that's added if it's something that's not in the reaction. If we're adding neon, we're adding more gas, which is really going to take up space in the container. If we're taking up space in the container, it's just a fancy way of saying that we're increasing the pressure. If we're increasing the pressure, we're going to shift towards the side with least moles of gas. And so in this case, we'll shift to the right. And that is our end of our practice on Le Chatelier's principle.